This guide is for beginners or for people that would like a refresher on how to build a computer. For those of you that already know how to build a computer, you may learn something from this guide, and for the absolute beginner, after watching this video, you should be able to build one on your own. If I had to compare it to something, your processor is like the heart of your computer. So with that in mind, the first thing you need to know is which processor are you going to buy? In order to find that out, the first thing you need to ask yourself is, what do I need this computer to do? If you're just going to search the internet, watch videos, and play games that aren't very demanding like League of Legends, Overwatch, or basically any other esports title, then you can settle for a lower end CPU like a Ryzen 3 1200 or an Intel i3. Now what I just said might confuse you, so here is a quick explanation. Those processors I just mentioned have a lower core count than most processors and have a low to medium range clock speed. Inside a processor, the more cores and threads you have, the stronger it will be and the more it will be able to handle. The clock speed of a processor kind of follows that same principle in that the higher the clock speed is, the stronger it will perform. Some programs and tasks are more demanding than others. For example, League of Legends could be run on a single core processor, while advanced 4K video rendering and special effects would need 8 cores with a high clock speed to perform at the expectation. If you want the best processor for you, look up the game or programs that you plan on running with the phrase recommended requirements afterwards, and there should be plenty of articles or videos telling you which processor you should get. As the name implies, this part is to keep your processor cool. A processor gets very hot while performing tasks and needs help staying cool in order to keep doing so. Without a cooler, your processor would fry. Now, most processors have an automatic shutdown feature when they get too hot, but either way, you never want your processor to get there. There are two main ways to cool your processor, which are air cooling and liquid cooling. Both have their benefits, but for a beginner, I would recommend air cooling since it's a little bit easier to install. Now, some manufacturers sell CPU coolers with their processors, like AMD with their Ryzen chips. Most of the time these processors are sufficient, but if you plan on doing something like long-term gaming or extreme content creation, then I highly recommend getting a beefier cooler. Now, your motherboard is the main hub for your computer because this is where all the parts will get connected so that they can work together. There are many different motherboards to choose from, but after selecting your processor, there will only be a few specific models that you can use. The way you should think about this is as follows. Each processor belongs to a specific generation. Intel has processors that belong to a 2nd generation, 3rd generation, 4th generation, all the way up to the current 9th generation. Each generation has its own name, which you can easily Google if you would like to know them. As for AMD, they have Summit Ridge, Raven Ridge, and Pinnacle Ridge, or as they are more commonly called, Ryzen processors. The reason you need to know that is because there are motherboards that are built specifically to support 1 and sometimes up to 2 generations of processors. But not only do certain motherboards support specific generations, they also support specific socket types. Each processor has its own specific socket type that you need to know so that you can choose the correct motherboard. So when selecting your motherboard, you need to know two things. Does it support my processor's generation, and does it support my processor socket type as well? There should be a few options for you to pick from once you find motherboards that fit those two qualifications, and by the way, some will be more expensive than others. From my experience, the cheaper ones will be plain looking and sometimes have issues, and the more expensive ones will have a lot more features and look a lot nicer. If I were you, I would just get something in the middle. RAM stands for Random Access Memory. The more you have, the more internet tabs and programs you can have running at once without experiencing lag. Some programs require more RAM in order to run smoothly. To make this simple, if you plan on streaming while gaming or doing content creation, get 16 gigabytes of RAM. If you're just going to game, search the internet, and watch videos, then get 8 gigabytes of RAM. You can get less or more than that if you want, but since this is a beginner's guide, that's my recommendation for you. Also, small side note, if you're buying an Intel processor, the frequency of your RAM really does not matter all that much. But if you're getting a Ryzen processor, try to get higher frequency RAM if you can afford it. It will help with your performance, not necessarily enough for a beginner to notice, but it will definitely help. One last thing about RAM, there are actually different types of RAM. If you want to know which kind of RAM you need, if you check the specifications of the processor you buy, it should tell you there. For the most part though, if you're buying a processor that was made in late 2015 onwards, you'll most likely need DDR4, and if you bought a processor that was made in 2015 to as early as 2007, then you will need DDR3 RAM. I'm not going to give you any suggestions for processors earlier than 2007 because you should not be building a computer with hardware older than that unless you have a YouTube channel and you're just trying to do something crazy. So inside a graphics card is a graphics processing unit, aka a GPU. Now there are a lot of different ways to think about which option would be the best one for you. However, I'm going to teach you the most straightforward approach so that you can choose the best card for you regardless of what brand you go with. There are three main specifications for graphics cards that let you know how good they are: the clock speed, the amount of VRAM, and the memory bus width. The analogy I like to use to explain these specs is a street. Basically, the busier the street, the better the card is. Think of the clock speed like a speed limit. The higher it is, the faster the cars can travel down the street. Think of the amount of VRAM like how many cars go down the street per cycle. And then think of the memory bus width as how many lanes there are on that street. The cars are supposed to represent data, and basically the more cars you have moving and the faster they can travel, the better performance you will get out of your graphics card. However, if you can't understand that analogy, here is my recommendation to you. Do not ever get anything lower than 1000 megahertz clock speed, 2 gigabytes of GDDR5 RAM, and 128-bit memory bus width. It's not that specs lower than that are unplayable, but they will definitely be less enjoyable. This one is pretty easy to understand. You need a power supply so that all your parts can have the power to run. Parts like your processor and graphics card will have a recommended wattage when you look at their specifications. If you add up that recommended wattage and buy a power supply with that much wattage, you should have more than enough power to run your computer successfully. For the most part though, what I have come to learn is that if you use power supplies that come with a little less wattage than what they recommend in the specifications for your parts, you'll usually be fine. I'm not saying you should do this, but I've been able to run computers where the recommended wattage was 650 watts on a 450 watt power supply. The other specification you need to look out for when buying a power supply is the rating. From lowest to highest, they are as follows. Non-rated, 80 plus, 80 plus bronze, 80 plus silver, 80 plus gold, 80 plus platinum, and 80 plus titanium. The higher rating you have, the more power efficient your power supply will be. In detail, this means that your power consumption will more accurately reflect what your computer needs depending on what tasks it's being asked to run. Also, my warning to beginners is that out of all the parts to try and save money on, don't let one of them be your power supply. Cheap power supplies are more likely to have issues, and the worst case scenario is that if your power supply goes bad or fries, it has the potential to fry all the other components in the computer with it. That doesn't mean get an 80 plus titanium rated power supply, but if you do get something 80 plus bronze rated, you should be fine. Also, there are different sized power supplies, but unless you're getting a mini ITX motherboard, just get the regular sized ATX power supply. Now notice I wrote drive, not hard drive. In this day and age, what you want your computer's operating system to work off of is a solid state drive. Long story short, this will make the turning on and off and the load times of your computer significantly faster. Now, if you like storing a lot of photos, videos, or other files, then yeah, you can get a hard drive for additional storage, but if you don't, just buy a solid state drive. And in case I didn't just make this clear, you can have multiple drives inside your computer. This is the glue you will be using to keep your CPU cooler on your processor. The reason we specifically use thermal paste is because its compounds make it better for heat transfer. The other reason we use it is because on a microscopic level, the lid of your CPU and the base of the CPU cooler have cracks that the human eye cannot see. What the thermal paste does is it helps fill up those cracks for a more clean heat transfer from the CPU to the CPU cooler. Now, before you pick the prettiest case you can find, you need to make sure that your case will fit the motherboard you selected as well as all the other components. Now, unless you're getting a giant graphics card or CPU cooler, you pretty much don't have to check the specifications for either of those. If you got an eATX or ATX sized motherboard, then you will need an ATX sized case. If you got a micro ATX sized motherboard, then you will need a micro ATX sized case. And finally, if you got a mini ITX sized motherboard, you will need a mini ITX sized case. Now, most ATX sized cases will actually support micro ATX and mini ITX motherboards as well. However, if you do end up getting a giant ATX sized case with a mini ITX sized motherboard, your build is going to look really silly when you have all of your components crushed into a corner and the rest of your case empty with nothing inside of it. After you get the right size, there are a lot of other features to consider before actually buying your case. For the most part, read the reviews and see what people are saying about the cases you're interested in so that you can see if it's a good fit for you. But the one thing I highly recommend you look for built into your case are SSD mounting brackets. Otherwise, you will have to buy one separately. Now, I hope I can safely assume you are a man or woman or non-binary of culture and are going to get Windows. There are a few sources where you can get a licensed key for cheap, like scdkey.com. If you use my code KY1, I don't get any money for it. It's literally just there to help you guys save money, and eBay and other online markets. However, if you want, you can get an unactivated version from Microsoft's website for free. Disclaimer, this is not illegal, no matter how many dumb people in the comments try to convince you otherwise. It is not stealing or pirating Windows, which I do not support, by the way. Now, that should be enough explaining. I've got all these parts behind me. Let's get into the actual building process.